Hello children, welcome to our physics lesson on SBC TV. I am myself Dave Gopal from English River Secondary School. I will be assisted by Mr. Philip Kado, our lab technician. The topic I've chosen for you today is waves. This is a topic that is suitable for S5 students, and it will be good also for the S4 because waves is in the program, and even the S3 because it is in the program of study also. And why not for everybody at home, because there should be no partition in learning. Now, I remind you, you are not only watching TV, you are following a lesson. I can see that some of you are just seated without any material in front of you. Make sure you have your pen, pencils, and paper if you have to write down something. I will even suggest you have your phones if in case you have to do some screenshots, because you will not have time to copy everything. Then you can work on it later on at your own pace, right? So, waves. These are the lesson objectives according to the IGCSE syllabus. Demonstrate understanding that waves transfer energy without transferring matter. Describe what is meant by wave motion as illustrated by vibration in ropes and springs and by experiments using water waves. Use the term wave front. Give the meaning of speed, frequency, wavelengths, and amplitude. Distinguish between transverse and longitudinal waves and give suitable examples. Describe how waves can undergo reflection, refraction, diffraction. Describe the use of water wave to demonstrate reflection, refraction, and diffraction. And for the extended candidates, you will have to recall the use of the equation V is equal to F lambda. Describe how wave fronts and gaps size affect diffraction through a gap. Describe how wavelengths affects diffraction at an edge. So what is a wave? For this, I will demonstrate a simple experiment. Mr. Kado will be helping me with a rope. Look what is going to happen. This is a rope, I'm going to cause a disturbance in it, and you will see what happens. Follow, I will make only one disturbance. Can you see that this disturbance is going throughout the length of the rope? But the rope did not move. The rope is still in my hand. It is only that the disturbance that, right? So this is a wave. A disturbance through a material medium without the material moving bodily with it. I will demonstrate another wave using the slinky. Look at this one. I am going to move this slinky in and out. Okay, and now I will move it in another way, left and right. In both cases, again, you have seen the disturbance traveling, but it is not the material traveling bodily with it. And this is a wave. And as it moves, as the disturbance moves, it carries energy with it. Therefore, a wave, when something is vibrating or oscillating, the disturbance can travel through the medium without the medium traveling with it, and it is a means of transferring energy without transferring of the matter itself. Now, types of waves. You have seen that I produced two types of waves with the slinky. Firstly, when I was moving the slinky in and out, the wave was traveling in the same direction as the disturbance. This is one type of wave. There is another type of wave. When I was moving it left and right, the wave was going again at right angle to the disturbance this time. This is another type of waves. Therefore, we have got two types of waves. The first one is longitudinal, when the direction of wave motion is the same as the disturbance. And the other one, when the direction of longitude of the wave motion is perpendicular to the disturbance. As you can see, the L is in line with the disturbance, T is at right angle to the disturbance. So these are the two types of waves we have. Now, in longitudinal wave, as we have just said, the oscillation is in the same direction as the wave moves. And transverse wave, here we are. The wave motion. You have seen that the wave was moving. It moved up, down, it goes like this. If you have understood the two types of wave, longitudinal and transverse, you have understood almost everything. Now let us come with a nomenclature, with a literature behind it. When the high point of the wave is called the crest, and the low point is called the trough. This dotted line is representing the rest position of the medium, of the rope, of the slinky, of water, whatever it is a rest position. So the material moves up and down, and up and down. This is make one wave, two waves, one wave, two wave, and then you have got another quarter of a wave. The top bit, crest, bottom part is a trough. Now, how much disturbed it is from the rest position is called the amplitude, and the length of the wave is called wavelength, denoted by the symbol lambda, which is a Greek alphabet. Now, the other type of wave, the longitudinal wave, you did not see that pattern of crest and trough, but you have seen a series of compression and rarefaction. Compression means that the particles, that the slinky bits come closer together, and rarefaction when they move further away from each other. So there is a series of compression and rarefaction. So the two types of waves are here. Your longitudinal wave, compression, rarefaction, it goes on like this, and your transverse wave. Even this longitudinal wave can be transformed into this pattern using a cathode ray oscilloscope, some form of a television that you see at the hospital checking patient heartbeats. Okay? So they can produce this type of waves. Now, here again, the wavelength is between 2 points that are in phase. 2 compression or 2 rarefaction, or 1 point here on this wave to its corresponding point on the other wave. These are all wavelengths. For example, here also, I can have these two distances as the wavelengths, these two distances as the wavelengths, or this point to this point, the wavelengths, they are all the same. It should be 2 points on the wave that are in phase. Now, what are the terms that we use to describe wave motion? Wavelengths. We have just mentioned it, lambda, the distance between two successive crests or trough, or any 2 points on the wave that are in phase. It's not necessarily between the crest and the trough, but any 2 points that are in phase. The frequency, this is the number of disturbance I'm producing in 1 second. Frequency. And the unit is hertz. Then the speed of the wave is the distance that the wave travels in 1 second. So the unit is going to be meters per second. The amplitude, the maximum disturbance, the disturbance, the maximum displacement from the undisturbed position, from the rest position. How far it moves from the rest position, that is amplitude. And the wavefront, like in water waves, you can see the waves moving. So it is an imaginary line through an advancing wave, and again where all the particles are in phase, wavefront. Now, examples of transverse wave. You have seen the wave in the rope, the water waves, and another solid examples of transverse wave is a light wave and all the other electromagnetic waves. Light wave form part of a whole family of waves called the electromagnetic waves. This is a ripple tank. It is not in my scope to show it to you today, but you can, at school, your teacher will be demonstrating it. What it has got a bulb, powerful one. It has got an electric motor, which is going to, when it runs, it vibrates this dipper, and this dipper is going to produce a wave in the water in the tank, and you have got a sponge lining so that the wave is not reflected. So, and then this light is going to show all the crest of the wave will act as a lens, and you will see the pattern on a screen down there. You will be able to study the different aspects, reflection, refraction, diffraction of waves using the ripple tank, right? So this is for the water wave, which you study from a ripple tank. And this is the electromagnetic spectrum, a whole family of waves. You've got the gamma ray, X-ray, the UV rays. Your eye is sensitive to only this bit of the whole spectrum, only this bit. And this is all the light that you have in your white light, the colors of the rainbow. And then you have got the infrared, microwave, all these things you cannot see. When you're using your phone, you have got waves coming and going.